Let's now have the implementation of the velocity of the parachutist that we have covered in the previous lecture video. So we start now with the Excel. So you first have to open your Excel. Then now we need to enter the labels and also the values for this one, for the parachutist problem. Okay, let's have 68.1 is, then we have 12.5 and we have 2. This is in kilograms, this is in kilogram per second, this is in seconds. Okay, let's also have our time, which is 0, 2, 4, 6, 8, 10, 12. And then for infinity, let's have a big number, let's say 1000. Let's have the velocity values for numerical. Then let's also have the velocity values for the analytical. Oops, let me adjust that. Now, having made all of this, having the labels and the values, let's first assign names to these values so as to have more control over these values. For that, we'll have 68.1, let's label this as M, that is for mass. 12.5, let's label this with CD, that is the coefficient, drag force coefficient. Then for 2, let's have dt or delta t. Now to do the labeling, just highlight this 6 cells, then go to formulas, then you go to create from selection. Click create from selection. Create names from selection. Then the names that we shall take will be the names at the left column. That is M, CD, and DT. So we check this one. Then OK. So let's try to check. Now, as you can see, when we click this cell, the label is M. If you are to differentiate, for example, this one, this cell, the label was A9. However, this one, before this is B3. However, we have changed the label to M. So as with this one and this one. So by so doing, in our formulas, you just have to use the labels or the names as reference to the values contained in these cells. Okay, so for the velocity of our parachutist, we have had this differential equation, then we got this solution, this exact solution. This is from this expression we can get the analytical values. So this is of this form. Now let's do that in our spreadsheet. That will just be, it's 9.8 times mass, that's 68.1, so that would be m. GMC, so divided by CD, then times 1 minus exponent. Exp means the e to the power of something. The exponent negative of c divided by m, then times t. T here should be the time here, so that would be A8. That is this one. Okay. Right, what is this? What's the problem? MCD. Why? Oh, okay. I see, it's this one. It should be CD. Okay. So this is this one. Okay. Then if we want to take the velocity at time equal to 2, time equal to 4 seconds, 6 seconds, just have to drag this down so as to populate the this formula, just like this. So as you can see, these were the values that we have come up with in the previous lectures. Now, so we have the analytical. Let's have now the numerical. Since in our numerical, it involves much in programming, so we will be using the VBA, the Visual Basic in Applications package of Excel. To do that, we have to just click the Developer tab. In the Developer, now Wait, before I proceed, just in case you don't have the developer menu, you first have to go to File, then click Options, and the options, click Customize Ribbon, and the Customize Ribbon, check this one. By default, this is unchecked. So if we are to look at that, so there will be no developer menu. So uncheck the developer menu. Okay, because it's in the developer menu that we can access our VBA. In the developer menu, click Visual Basic. Now, if you want to the shortcut, you can just click Alt F11. Now, if we are in our editor. In our editor, just click Insert and then Module. So here in our module, you can then create our code. This is now the code window. Now in this code window, there's already this this program. I'll just explain to you because I already encoded this program before doing this video. So just to save us some time. Okay, now having this code in our VBA, we then go back to our spreadsheet. Then as you can see, we are to implement from this one, we came up with this one. So this is actually the Euler's method. That is, you can compute for the values of the velocity given the initial value of the velocity, the slope, and the time step. Or you can also say the step size. So this is the expression that you are using in our code window in the VB editor. Okay, so this one, we can notice this one. This is actually this is VI, so VI. Then this is the slope, and this is the step size, the H. After this, it will be this one. Should be the new V or the new H. This is Y in this code, but this is actually the velocity. So this will be updated after this is evaluated. But later I'll explain this. So let's continue. Let's go back to our, oh, I forgot something. As you can see, this in this code, we have created the function Euler. And in order to access these procedures, we need to call this function named Euler in our spreadsheet. Then another thing, you have to take note of this, the arguments of our function. It's dt, the initial time, final time, the initial value of your velocity, mcd. So it would be like this. This one, since you want to use the Euler's method, the the code that we have created. So in here, let's have Euler. Then first is dt. So this dt is in reference to this value. Then it's ti. Ti is, oh wait, I forgot. This one should be 0 because this is the initial value. It would be here that we need to use the code that we have created. So this should be here. First argument is dt. Second argument is ti, which is the initial value. Then the ti plus 1, the tf. Then the initial value of our velocity. Then we have m and cd. Okay, so we have 19.6. Now, okay, I'll just explain later. Now, having this, maybe you can remember that these are actually the numerical value that we got in our previous lecture at time equal to 2 seconds. So just drag down and you will have this. I have it here with me. So just to check, 844.82. Okay, check. 1249.96. Okay, check. Now, what happened between the X and our spreadsheet and our VBA? Now, in this one, this is equal to Euler. Euler is a function. As you can see, this is a function. Then we have, in doing this, we actually are calling the function Euler. And in calling the function Euler, we have sent to it these following inputs. That is the dt, the a8, a9, b8, m, and cd. So Euler will take these 5 quantities as the inputs to this function. And then those 5 quantities will be stored in this one, in dt. Then the a8 will be stored in this variable ti. The value of dt in our spreadsheet will be stored in this variable dt. The value of a8 in our spreadsheet will be stored in the variable ti. a9 will be stored in tf. Then what was that? b8. Yes, b8. So b8 will be, yi will be equal to b8. The m in our spreadsheet will be stored in m here, and cd there will be stored in cd here. Now, having this as inputs, this function will then process, do the iterations. After that, it exits, then returns the updated value by this Euler is equal to y. That is, this one, this function Euler, will return the value of the updated y. And this y will be the output as seen here 19.6. So basically what happened is your spreadsheet now becomes the place where you can input your values, then receive the output. After you input the values, within the values, the input should be sent to our VBA. Then the output from our VBA will be sent back to our spreadsheet.